Okay, today we're going to talk about how to find the area of pieces of circles. This first example is a sector of a circle, and a sector is just a chunk of that circle that we want to find the area of. The formula to find the area of sectors of circles is area equals pi radius squared, because that's the area of a whole circle, and we need to multiply it by the portion of the circle we care about. To calculate the portion of that circle, we're going to take the angle divided by the whole amount of degrees in the circle, which is 360. So for this example, the first thing we need to do is identify the angle of the shaded region. We know the angle of the non-shaded region is 200 degrees. So if I know there are 360 degrees total, and I know there are 200 in the non-shaded region, that leaves 160 degrees for the shaded region. I also know that the radius is 8 inches long. So now I'm just going to plug it into my formula. So area equals pi 8 squared times 160 divided by 360. So now we're just going to take our calculator and plug in our formula. So pi 8 squared times 160 divided by 360. And we get 89.4. So we know that the area of the sector is 89.4 inches squared. In our next example, we have an annulus. An annulus is two circles, one inside the other. And if you can imagine, this kind of looks like a donut, and the center is being removed. And the way that we remove something is by subtraction. So I know that I have this larger circle. In order to find the radius of the larger circle, I have to figure out how long is it from the center to the edge of the large circle. I know from the center to the small circle is 4, and the small circle to the edge is 8, obviously not drawn to scale. And so I know the whole radius of the large circle is 12 centimeters. So I can plug that into my area formula. Area of the large circle equals pi 12 squared. So we'll calculate that. Pi 12 squared. 452.4. Now we'll calculate the area of the small circle. I know the radius of the small circle is 4, so the area of the small circle is pi 4 squared, which will be 50.3. Now, in order to find just the shaded region, it's the large circle minus the small circle. So we'll take 452.4 minus 50.3. The area of the annulus is 402.1 centimeters squared. Our next example is two shapes combined. If you can imagine, this area right here is a sector of a circle, like in the first example. We also have a triangle that looks like it's being removed from the sector of the circle. So again, removing or taking something out is subtraction. So the first thing we need to do is find the area of the sector. And then we'll take away the area of the triangle, and that will leave us with just the shaded region. So we know this box means 90 degrees, and this is a special kind of triangle, so both the base and the height of the triangle are 17. So to find the area of the sector, remember from the first example, it's pi radius squared times the angle over 360. So it's going to be pi 17 squared times 90 divided by 360. For the area of a triangle, we know it's base times height divided by 2. So it's going to be 17 times 17 divided by 2. And we'll subtract those. So we'll start first with pi 17 squared times 90 over 360. We get 226.9. So let's write that down. And we'll subtract that from 17 times 17 divided by 2 from 144.5. So finally, our answer will be 82.4 centimeters squared. Our last example of the day will be an area of a sector problem, but in this case, we're looking for the angle. So we're given the area and we're given the radius. So please recall that our formula is area equals pi radius squared times the angle divided by 360. And this is what we're looking for, so that will remain a lowercase a. We know that capital A is the area, and that's 40 pi. So we'll plug that into our formula. We also know that the radius is 20, so we'll plug that in. So we get 40 pi equals pi 20 squared times a over 360. So to begin solving, the very first thing we can do is cancel our pi's. We have pi on both sides, so they can just go away. So 40 equals 20 squared is 20 times 20, and we can calculate that. And we get 400. So 40 equals 400 times a over 360. Now we're just going to apply some of our algebra skills that we've been working on all year. I know that this operation right here is multiplication, so to undo it, I will divide by 400 on both sides of my equal sign. Sometimes we draw this line to keep us organized. 40 divided by 400 is 0.10 equals a over 360. There's one final operation to get our angle all alone. We know that this operation right here is division, and the opposite of division is multiplication. So I will multiply 360 on both sides. So I get 36 equals a, which means my angle is 36 degrees. That's it for today. Thanks so much.